New Yorkers, listen up. Are you sick and tired of those systems that say trains are 1 minute away and never come? Or maybe your specific train station doesn't even have one of those systems. As New Yorkers, we are at the mercy of the frequent MTA dumpster fire service. I live in the Williamsburg-Greenpoint area, where my main line is the L train. I think a lot of you know what's up. Anyway, MTALens has created a mobile app which actually tracks your train in real time using MTA data. Using optical character recognition, a user is able to take a photo of the train logo and get up to an up-to-date location of the train. Let's see how the developers of MTALens is about to save us New Yorkers.
Hey everybody, my name is Luke, and together with my teammates Danny, Dzmitry, and Oleksii, we are MTALens. We designed MTALens to help New Yorkers with the subway conundrums we all experience. If you're outside a station, do you have time to get a coffee before your train? If you're on a platform with no timing board, how do you know when the next train is? Is it worth it to get on this packed train, or is there another one right after it? With MTALens, you can get all this information in a novel way and connect with your fellow riders for up-to-the-minute alerts, all in an elegant, intuitive user interface. Let's walk through a basic user story to see how this all works. Suppose we have a user, Ben, who's starting a new job today and he wants to make sure he's not late. He opens MTALens and signs up for an account. Guests can access the basic functionality of our app, but to use all the features, they need to make an account. Once Ben creates an account, he'll be shown our homepage map. Since Ben lives at Full Stack Academy, 5 Hanover Square, his nearest subway stop is Wall Street Station on the 2 and 3 lines. Our app gets Ben's location information automatically and identifies Wall Street as his nearest station. The 2 and 3, then before Ben leaves his house, he heads over to our info tab to check all the subway service. The 2 and 3 have good service, so Ben is ready to go. Now I'll hand it over to Danny for what happens when Ben gets to the station.
Thank you, Luke. Now that we're at the station, Ben will click on the camera icon and take a picture on the train line to know when the next upcoming trains are. It puts the train line into the real-time feed and displays the following uptown and downtown trains. Can he grab a quick meal? The next train is coming in 10 minutes, so he looks like he could grab a coffee and bagel and be on his way. Schedule list is also where user interactivity comes into play. Ben could report if a train is congested, or can also see other reports from other users as well. So Ben is a little too, as the next train comes, Ben is a little too close to strangers for comfort and reports it. One click is all you need. In addition, you can connect with other users with a global chat to discuss the state of the MTA, whether it be unexpected alerts or delays. Here, another user, John, sees that the upcoming train has been reported and goes to the chat and says, "Thanks for the heads up." It's as easy as ABC. And now here's Alex with the stack behind MTALens.
Hi everyone, thank you Danny. I will tell you about technologies we are using in our project. For the front end we use React Native and Expo. React Native provides us render, navigation and data input. The Expo is the easiest access to the camera, geolocation and deployment. For the back end we use MTA API, Google Vision, Node.js and Firebase. Google Vision is the tools let us recognize the input data. The MTA API is the real-time subway state and upcoming trains. The Firebase we are using to keep our chat information and congested trains. Also we're using Firebase authentication and Firebase functions. The Node.js is just JavaScript-based runtime environment for building JavaScript applications. Now is Dzmitry tell us about challenges in our project.
Thank you, Alex. So the first difficult part for us was to connect all parts together. So when Ben takes a picture, we make a call to Google Vision to get a trained character, and then using his geolocation, we make another call to MTA real-time API to get an actual schedule. One of our problems was to understand MTA GTFS API because it contains a huge amount of information for all trains and stations. We also had a lot of challenges using React Native and Expo on iOS and Android. For example, Expo camera wasn't working in our application for Android, so we got it to work only using Android original camera. Also, currently we're using Google Vision optical character recognition default model, but we will definitely increase accuracy and speed up performance by using a custom model. We would train our model to detect only letters and numbers in the color-shaped circles. Our next feature is to implement train animation on the map so user can see exact location of the train. Bent won't be late today. How about you? You can check us on the GitHub. Thank you for your time.
Sounds exactly how it go with my daily transportation. It even has a chat feature to let users update other users. It reminds me a little of Waze's map talk feature, where you can note exactly what is happening even if it isn't up to date on the map yet. I've said before, I'm a sucker for practical ideas, and this is about as practical as it gets for New Yorkers. What's really impressive is that they were able to use technologies like optical character recognition through Google Cloud Vision's API and Firebase to build this out. Technologies we don't teach them in the core curriculum at Full Stack. Thank you, MTALens, for your demo, and for all of you watching out there, I know you will want to check them out.